Hello again and welcome to ISAC Software Academy Linux course. This lesson will be covering the basics of the Linux kernel, and as such we'll be covering some of its more outside history style things and less technical on it, but we'll also be covering some technical aspects, and I hope that it explains a lot of questions that you might have about the kernel. Now, the kernel is effectively the brain as far as the software goes. Its entire job is to effectively interface between hardware and software. It's also what allows a lot of the more advanced features in Linux. So the kernel is, now when I say the kernel like this, I mean the Linux kernel. There is a kernel in almost all operating systems. In fact, I can't think of one that wouldn't have a kernel. It just doesn't seem logical without one. There are different types of kernels, but we'll get into that later. So when you see the kernel, as you can see here, this means the Linux kernel, and I will specify when it's not the Linux kernel. However, to put it in more simplistic terms, the kernel is effectively a middleman between hardware and software, and it provides services to both. Now what that means is that when hardware wants to communicate with software, it sends a message. That message is translated and then given to the software, and this happens in the reverse order as well. Software will send a message, it will get translated, and then the hardware will obviously receive that message, and both will act according to those messages, and so on and so forth. Now, the kernel is regularly updated to newer versions so that it can handle more things, have more capabilities, more features, but also to be more stable and more reliable. This is done, in the case of Linux, by volunteers all over the world. They do it for nothing. They do not get paid for it. They do it for the love of doing it, because they want to do it. So it has been estimated in the billions to reproduce in a consumer or business sense. If you actually paid the people that did this, it would be billions to recreate it. So it could possibly even be more by the time you listen to this. So it's a lot of work. I think it was roughly 15 million lines of code for the latest kernel, so it's probably going to be even more than that. It's just going to keep growing, so it's a lot of code. Now, as I said, it's used to interface with the hardware, but what I wanted to get at was that it's not always directly interfacing. This is where modules come into it, and these are very similar to drivers. A lot of times it's used interchangeably, but a module is effectively something that can be plugged in to the kernel to expand its functionality and improve stability. Not always do you want to use the default setup, so that is there as well. Now, the kernel is freely available to download, including in source code form, and you can read and learn from it, and obviously contribute if you wish to. Now, you could download this in general from www.kernel.org, so you can go and get it there. However, one thing to keep in mind is if you're using Ubuntu in particular, they actually have kernel.ubuntu.org that you can go to get Ubuntu kernels. Now, it is a monolithic kernel, and this is different because it includes as much as is possible in kernel space rather than trying to limit what's in kernel space. What that means is that things that could be moved out into user space are kept in the kernel instead. A microkernel, on the other hand, keeps as little as possible in the kernel and makes it smaller. This isn't always the best option, but it is an option. It really does depend on applications and what you actually want to do with it. Now, the version numbering is done according to an even-odd system in the older versions. Up until the 2.6.x versions, this was the case. And how this worked was that if it was 2.4, so the 4 being the even number, then it was a stable release. So anything that was 2.4.1, 2.4.3, 2.4.8 didn't really matter, so long as it was 2.4 point something, it was a stable release. However, a 2.5 release meant that it was an unstable release tree, and that therefore meant that you would most likely be looking at stability issues. So it's not always the case, but it can happen. As of 3.0, this is no longer the case. The change to 3.0, however, as a tidbit of information, was not because of any major improvements. It was actually the 20th birthday of the kernel, so that's something to keep in mind. We will now cover some more practical sides of the kernel. Now, I'll just show you, this is the kernel.org website. As you can see, at this particular point in time, there is the 3.6.6 kernel that is the latest stable. However, there is also a 3.7 RC5. So these are available for download as source, and there is obviously a lot of information here that you can go through. We're not going to do that today, but that is there available. The other thing is, this is the kernel.ubuntu.com site. Now, I've gone into this specific one here to get the latest stable one for Ubuntu. Now, I'm actually not running Raring. At the time of this recording, it was not released. However, I'm going to attempt to install this, and hopefully it will run with the version I'm using, which is in fact Precise. Now, I've already gone through and downloaded these ones here. I'm using a 32-bit, so I got the i386 rather than the AMD 64. If you are attempting to go through this, for a start, back up all your data, because if you can't get back in, then you may have trouble getting it again. However, if you're using a 64-bit, then you'll obviously want to use the 64-bit ones here. I'm not, so I can't use those. Now, what I have done is I have put them all directly into the downloads folder. So what I'm going to do is just move those out, purely because I don't want to have to worry about it all at the same time. So we're going to put them into our own home folder, and we'll call it kernel 3.6.6 because that's what we've got. And that will be a lot more simplistic. Now obviously we don't need these up anymore, so I'll just close these and we'll go into our kernel directory. Now at this point I already have all of the debs, so I don't actually have to worry about it so much, but you would have to download these first. Now the command I'm typing in here is sudo dpackage -i for install, and then I'm doing a star.deb. Oops, I forgot the .deb. So when we do this, it should, in theory, presuming I haven't stuffed anything up, install the new Linux headers, and obviously the new Linux image as well. Now in doing this, there is a good chance I will break this system, purely because this Ubuntu image is designed to work with a version of Ubuntu I do not have. I can't be sure ahead of time that it will work or it won't work, or whichever we want to see. All I can do is try it and see if it works, which is what we're doing now. Effectively, if this works, we should have a more up-to-date kernel, which means we'll have more features available to us, as well as also having more stability. Now this is in theory. Obviously you can go up to a more recent one and it may even say stable, and it could actually be unstable. This is something you do need to keep in mind when updating a kernel. Generally speaking, however, Ubuntu does their best to keep things stable with their operating systems, so we should be right. Alright, so I just fast forwarded a little bit, and I did this because it was taking quite a bit of time, and it does generally do that. However, if we scroll back up, I just want to show you a couple of error messages that happened here. As you can see, it's actually specified here that it is not supported, and that it's got a bad return status, and etc, etc. This is more than likely going to be because it's actually designed for a different version of Ubuntu than what we presently have. It has actually, however, gone through, compiled these. Now we can actually see this by going to the /boot directory, which you may recall from previous lessons. Now as you can see, and you'll notice the contrast between the two, we're currently running the 3.2.0-32, and I think you'll find it'll actually be this one that's presently running. This is the one we're going to be running when we reboot. So I'm going to do a reboot now, and in theory, presuming it all works, we should be up and running again very quickly. But we'll be able to see without too much hassle that we have updated the kernel. Now at that point I'll end the lesson. However, there is a good chance it will fail, so keep that in mind. Starting to load up now. I only know this because I can actually hear the hard drive in the background, so yeah, this is otherwise it's just a blank screen at the moment. But here we go, we've booted back up again, and we'll now see if everything's working alright. So far so good, and we should in theory be able to do a version test, or at least figure out what we're using as a kernel. So we will enter in the uname -mrs command, and as you can see we are now running Linux 3.6.6, and that's obviously the generic, and so that it was successful. That's the end of this lesson. I hope you enjoyed it. Thank you.